So we're going to do some calculations. I want to make use of Sig Digs in these calculations. I'm going to start with something really simple. And I know we're going to get more complicated in physics, but we'll start with something that everybody knows. A rectangle, length and width. And of course, whenever you're doing a problem, you always start off with your given values, and it's no different in this room. Length, in this case, is going to be equal to 10.38 meters. And the width is equal to 9.2 meters. Okay, so somebody came along and made some measurements with a ruler. And what I'd like to do is first calculate the area of this rectangle. Okay, calculate the area of the rectangle. And before we do, I want to tell you what the rule is for doing calculations with multiplication and division. Because the rule is the same for multiplication and division, so I'll just throw it out there all at once. So when, and I'll just write, that means multiplying. When multiplying or dividing, keep as many Sig Digs, significant digits, as the least number of significant digits Sig Digs in your measured values. Okay, so when I say that, I mean the measured values I'm going to be using for this calculation are the length and the width. And so I'm just going to make a note of how many significant digits each one has based on the rules that we've talked about already. How many significant digits does the length have? 4. Yeah, so I'm just going to say 4 SDs. How many significant digits for the width? 2. So I've chosen 2 really simple ones. There's no zeros to confuse you. I don't want to throw you off. 2 SDs. Okay? So let's do our calculation. Everybody knows the formula for the area of a rectangle, but as always, you got to write your formulas, or your formulae. The formulae for this course are going to get progressively more complicated, and then they'll get easier, and then they'll get more complicated again. But throughout, we're going to keep on writing them at the beginning of problems. So we're going to say A is equal to L times W. We've written our givens, we've written our formula, standard format. And now we're going to sub in our values. So 10.38 meters. And I'm always going to write my units too. And I know that this seems like it's a simple thing, but it's something that's particularly important, and it becomes more and more important as the calculations get more complicated. Times 9.2 meters equals, and here I need a help from somebody with a calculator. What's 10.38 times 9.2? Let's go ahead. 95.496. Is there anybody that wants to second that motion? All right, motion carries. What are the units? Meters squared. Yeah, meters times meters, because we're multiplying the numbers together, but at the same time, we're also multiplying the units together. Meters times meters becomes meters squared, just like you would have x times x equaling x squared. We treat the units very much like variables here. So meters times meters, meters squared. And I'd like to round this off. So according to this rule, we say that when we're multiplying and dividing, we round so that the rounded value is consistent with the least number of significant digits in the given values, the given measured values. Which one is the least? 4 or 2? 2. Easy. How many digits should I round this to? 2. Peace, man. Okay. 95.496. Which should it round out to then? Yeah. Well, we could do. Yeah, let's round it first, though. Okay. So 95. No, the 4 is lower than 5, and the 4 is the one just after the 5. So it should be 95 meters squared. And 95.496 meters squared and 95 meters squared are not equal. So the way I've written it right now is actually incorrect. I have to indicate that it's been rounded, so it's approximately equal to. And you'll see some people write equal signs with a dot over top, which is what I do. Some people write wiggly equal signs. Some people will even do straight line with a wiggly line. All of them mean approximately equal to it to indicate that I've rounded it. So there's a rule here for rounding, built right into significant digits. And in the old math textbooks when you're in grade 9 and 10, it said complete the calculation and round to 2 decimal places. Well, you'll notice throughout our textbook, there's no n round to so many decimal places because it's implied right within the significant digits how much you have to round. Okay, so you'll never see that in our textbook because you guys know what the rule is now, okay? So 95 meters squared is the approximate value. And you could put it in scientific notation, as you say. So I could also say, instead of saying 95 meters squared, I could say 9.5 times 10 to the power of 1 meter squared. And again, 2 significant digits, but written in scientific notation. Now, that is for multiplication.